Welcome back to this course, Introduction to Careers in the Field of Information Technology. This is a presentation of coding boot camps. Section 3, Software Engineering Topics and Jobs. A recap of what we've learned so far. So we've had our intro to IT, we've had an overview of web design and development. We've talked about IT and web design and development job titles and job functions. We've looked at languages, frameworks, and content management systems. The topics for this section include an overview of software engineering, popular job titles and functions, programming languages, and we'll have a summary. So software is more than just program code. A program is an executable code, a set of instructions that serve some computational, computing, networking, or data purpose. Software is considered to be a collection of executable code that is executed on hardware or run on hardware. Associated libraries and documentations are accompanied with software programming because a lot of software programming is highly reusable, and libraries are just examples of software code that can be reused for the same purpose every time, such as networking software. Software, when made for a specific requirement, is called a software product. And engineering, on the other hand, is all about developing products using well-defined scientific principles and methods. Software engineering is an engineering branch associated with software development and the development of software products using well-defined principles, methods, and best practices. The outcome of software engineering is an efficient and reliable software product. It can also be a device such as a mobile phone where we have both a software hardware product. Some of the overview of software engineering. So quite often it begins with requirements and then analyzing the system, designing the solution, and then the developers go out and actually build the solution. It's tested and deployed to an operating environment, and customers begin using it, and then there is maintenance on the application, so checking and adjusting when needed, and then updating it as in adding new features. So these are all topics of software product design and even device design. Sometimes this is called an onion diagram. So we have here overall software development involves software design and programming here. So we can see how they are all really essential for one another and how they build on one another. The characteristics of good software. So a good software product is judged on what it delivers to the customer, to the user, and the business. The software must satisfy the following parts: operational, transitional, and it has to be maintainable. Operational tells us how well the software works. So was it developed on budget? Is it usable? Is the user getting any value from it? And is the firm getting any value from it? Is it efficient? Is it fast running? Is it correct? Does it have any defects? Does it have any bugs? The functionality, is it delivering the capabilities the user needs? Is it reliable? Is it up and running when users need it? Is it running all the time? Does it have a lot of downtime? Is it secure? Even the best software product in the world, if it's not secure, nobody's going to want to use it. So is it making sure that all data or all interactions are kept private? And is it safe? Does it satisfy all laws in the jurisdiction in which it's running? Transitional. So this is a very important aspect. Is the application portable? Can it be moved to different operating environments? Is it interoperable with other systems so we don't have to rebuild or reinvent the wheel? Is there any kind of reusability? What kind of adaptability is it? Can we extend it? Can we expand it? Also, can it be easily transitioned to other new people maintaining it? Because at some point, you have to think that the software will be transitioned to other teams. So usually roles, not specific people, maintain software. So considering transition is very important. And is it maintainable? So is it modular? Is it easily understood? Can the software go in and can it be debugged easily? Were best practices used in developing it? Is it flexible? Is it scalable? So can we scale it up and add more users to it? Some popular job titles are engineering fellow. So this is typically somebody who has the big ideas for software products. Obviously, chief information officer, who provides the strategy for software engineering and technology. Chief digital officer, again, very similar to chief information officer. Chief innovation officer. So innovation is not only computing and software development, but it can be innovation really in any way solutions are delivered. Chief architect, certainly an architect that is overall putting together the architectural, the runtime strategies for all of our software products. Software architects really design the application, its layers, its runtime environment. Software developers actually build the solutions, build the applications. We've been discussing software engineer. So software engineer does the development, the design, manages the software development lifecycle. And there is obviously a new person that's just coming on, is more of a junior software developer, is maybe just skilled in one or two programming languages. So a typical software engineering job description includes improving systems and improving quality by identifying issues and patterns, or developing operating standards and templates, enhancing applications by identifying opportunities for improvement. Does it put us in a new business? Does it maybe reduce risk? Developing applications based on user requirements and performing application integration tasks like unit testing, version control. So this is all parts of the software development lifecycle. Unit testing is a way of automating testing, so it can alleviate some manual, some tedious steps, and still validate quality. Version control gives us a repository in order to store all the versions of the code that were developed. Test-driven development and code refactoring are popular frameworks to deliver high-quality software in an efficient manner. And almost all software engineers should follow the software development lifecycle, or SDLC. It refers to that methodology for a clearly defined process of steps for creating high-quality software. The software development cycle is usually described in phases. So the requirements phase, where we gather really the needs of the users or the user community, planning how these requirements will be met. Design the software architecturally, so it's operating systems, the programming language, possibly databases, the actual software development, and then testing the software that was built and deploying it to the runtime environment for the users. So here are some very popular programming languages with some information on classes. Python is a very popular programming language, along with Java. Java runs many websites, many mobile applications. It is probably the #1 market share programming language, even to this day. I highly encourage at least taking some course in Java. C and C++ are related languages for specialized programming. Go is a very new language, and it's becoming very popular. And Kotlin is it's very similar to Java, but it is a very fast-running, efficient language. And training classes are available for all of these programming languages and more. Just a summary of what we talked about. So we had our overview of software engineering and popular job titles in the field, job functions, and programming languages. So our next section is mobile application development, topics and jobs. Please consult your learning materials for these and other classes. I highly recommend any of these. So Python programming, Python object-oriented programming, Introduction to Java, and Java Intermediate classes, C programming, C++, Go programming, and learn Kotlin. All of these are some or all of these are worth taking. Thank you again for watching this video on software engineering. See you in the next section.